I just want to thank, in particular, Giselle for helping me out in the preparations for this talk. And this is a bit of an old home week for me because I gave my first public lecture for the Bahamas National Trust in 1975. And Dave Campbell was my host, and it was at the British Sheraton Colonial. 600 people showed up. It was just amazing. It was talking about the results of a dive I made with the Alvin in the tongue of the ocean. That's me on the left quite a number of years ago, Harrier. And I've made a number of Alvin dives, and most of my research in the Bahamas and deep water has been with the Sea Link that you've heard plenty about. I've been on a couple of cruises with Shirley as well over the years. So, and that thing in the middle was the announcement that David had in the newspaper for a week, which generated quite a bit of interest. So I'm going to be talking about a couple of different things, these deep water mounds in an area that Gregor did not talk about in the northwestern Bahamas. First of all, a unique group of structures called lithoherms. We'll talk a little bit about their geology and their biology, and then the other mounds in somewhat shallower water. So to start with the geology, this was a map done by old-fashioned means in the late 60s, published in 1970, that shows this area off Little Bahama Bank, off the western margin in the Strait of Florida, and they mapped the topography in deep water as all of these up and down slope valleys. A bit later, NOAA came along and took much of that data and a little bit more data, because there was some submersible data known by that time, and they mapped them, but still as up and down slope mounds all along the margin of the bank. The work that Conrad Neumann, one of my co-authors, a carbonate sedimentologist and geologist, did work with looking at this area with the Alvin and with bottom profilers, and found this zone of mounds that he ended up calling lithoherms. I'll talk about that in a moment. But this is in an area where the temperature it's in the thermocline zone of the Bahamas, of the Gulf Stream, 6 to 8 degrees centigrade. We're talking of currents that can reach over 100 centimeters a second, a couple of knots, depending on conditions. The area is, this is a schematic diagram showing the lower slope lithoherm zone with the L's in it. Upper slope has got much coarser sediments. The sediment down in deeper water, 500 to 700 meters, is mostly pelagics, and I'll talk a bit about that in a moment. And if you zoom in, this is some of the topography that they found, and from this data and his submersible dives early in the late 1970s, and I came aboard in the late 70s, early 80s, he found these mounds to be north-south oriented, more or less teardrop-shaped or elongated, and up to 50 meters high. So we go back to our NOAA mound, and in the Google Earth has taken this data and made a complete hash out of it, because all they show are these little dots, which don't tell you anything about, they're not accurate at all. In about 2003, Neil Slowey from Texas A&M did some side scan work of a tiny little area, and zooming in on it, you can see that these are these north-south oriented, sort of overturned canoe-shaped mounds, and the zoom in gives you an idea. So these are these things that Conrad called the lithoherms, and some of them have very steep topography and very steep slopes. They're hard limestone, carbonate limestone, but they are layered. And you'll have layers of hard, very heavily cemented limestone separated by these less cemented material, looser material. The downslope parts of these, the downcurrent parts of these are very heavily eroded, and the samples include deep-sea corals in the rock. There's a close-up of a cross-section, and you can see the septa of this cross-section of a deep coral branch. And the way Conrad suggested that these things develop is that you have some small object on the seafloor, gorgonians or sponges grow on it, and you get a sediment shadow collecting behind, and under the circumstances of deep sea cementation, these things become hardened limestone over time. And you've got forams, you've got pteropods, and if you look at the limestone in cross-section, you can see the forams filled in with sediment. And I'm just going to go through this very quickly because Conrad's a great cartoonist and developed these ideas about how the cements form under these conditions, suggesting that organic material might be involved in the cementation process. And so I came up with this idea. It has absolutely no serious evidence to back it up. But here you have the circumstance under a high seawater stand and perhaps under a low seawater stand when the bank is completely exposed. You have a lot more organic detritus flowing off, and that may contribute somehow to the layering because you have different sequences of high and low seawater stand. But let's get to the biology, because I'm a biologist. We did a lot of work on the lithoherms, and we found that there's zonation even though you're in 600 to 800 meters of water. We have a series of different zones, crinoids and octocorals, on the down-current slopes and flanks, a colonial anemone or zoanthid that builds fans, arborescent fans on the crest, and then the Lophelia deepwater mound-building coral that Gregor talked about on the upcurrent slopes of the larger mounds. And then there's a rubble zone, and there are low mounds, maybe developing lithoherms in the interim, in between them. And so you have this sort of zonation with the current accelerated over the mound. And so let's take a couple of looks at some of the biology here. The crinoid octocoral zone, these are short-stalked crinoids that are all clinging to the edges of those layers. But there's a huge biodiversity in this area. There are polychaete tubes covered by zoanthids. There are glass sponges, spider crabs, feather stars. There are other corals. There's a closed anemone in the middle there, and so on. You get up to the top of the slopes. There's the Zoanthid Zone. It's got a great name now, Kulamanamana, used to be called Gerardia. It's still an undescribed species. The genus was named for a species in Hawaii that's harvested as gold coral. And these colonies they've been estimated to be anywhere from, on an average of up to 1,700 years old, plus or minus 300 years. So they've been around quite a while, and they form a great community, a great substrate for a whole community of organisms. There are chirostylid squat lobsters, there are feather stars, and a bunch of other things. There are anemones on these things. And it turns out that this gold coral is bioluminescent as well. And there are a number of other bioluminescent organisms. There are anemones, there are brittle stars, there are shrimps that are all bioluminescent. There's an understory of lithistid sponges among the gold corals. And then you get to the forward end, the upcurrent end, and here's a coral nose dominated by Lophelia, which is the main framework building coral. And those are the live colonies up there. Lophelia is found around the world, but dominates in the northern Atlantic and comes in a number of growth forms. And it has its own community. There's Lophelia there, and then all of those little sort of fuzzy orange, fuzzy yellow dots are small feather stars. Here's a close-up of them. This feather star, Comatilia, only occurs in the northern Bahamas and as far north as Georgia in association with these deep coral habitats. It's a brooder, so it doesn't give off planktonic larvae, and there's its attached post-larvae. So you never know what you're going to find here. There's a whole range of organisms that are associated with these habitats. Sea fans, and there's the brittle star that we've seen before. Then down in the rubble zone, there's quite an extensive small community of organisms, and out in the middle, in between the lithoherms, there are still other organisms, different species of stalked crinoid, different species of sponge, for example. And there you can see the rippled sediment as well. These are just some of the fan sponges, one of the ones that Shirley showed, and you can see the beginning of the sediment shadows. And just another example, this is a large black coral. These get to be over 2,000 years old, and there's a whole host of organisms associated with them. I won't go, I've got to zoom ahead here, give you an idea of how diverse these habitats are. Brittle stars, hydroids. There are some fish here, though. I'm an invertebrate zoologist, but there are fish. This is, I don't know if I can run that video. We don't really have the time, but this is Alfonsino, which occurs in some schools that shelter on the lithoherms. Wreckfish, and we've seen large sharks. This is a rare deep-sea shark. This is, I pulled this one off the web, Odontaspis noronhi, and a whole host of other organisms. You've seen the slit shells. That's a new species of crab down in the lower left. And then there are other mounds as well in shallower water. So we're now along, there's West End and the settlement point off Grand Bahama Island. And there's not much on this map at all. There's nothing between the deep mounds and the reef edge. But in Google Maps, at least, you do see a few little things up along here in about 300 to 400 meters, and others down here in 600 meters. And even though this is the lithoherms here, these are different, and they continue on down. This is one that's just covered with sponges, and it has its own fauna of small organisms. And this other area that I studied are these shallower water mounds, and they have their own zonation. So there are, for example, fields of crinoids of different species. I had a German paleontologist, Adolf Seilacher, come on one of my cruises, and he had studied the fossil crinoids. And here he was presented with the living ones, and it was right after a Steven Spielberg movie had come out. And so he came back from his dive and said, "This is Jurassic Aquarium." Because basically, if you were diving in the mid-Mesozoic, you'd recognize these things. Corals of a different species up at the crest, and then on the flanks, small gorgonians and black corals. And so we were looking at these crinoids mostly. That's my area of expertise for a number of different reasons, for paleontological applications, looking at different sizes, different filtering capabilities, looking at their responses to different currents. Here you have the red arrows showing you what the normal mean current is around this boulder, but the crinoid is orienting to the immediate flow. And we did growth studies as well, give you an idea of the size of these animals. We were able to collect them with the C-Link, tag them, put tie wraps around them, measure them, and collect them again up to a year later and measure their growth. We looked at their contribution to sediment in different habitats. We looked at their level of abrasion and incrustation of the crinoid skeletal pieces, all trying to relate this to the fossil record. And we discovered that they can actually lie down and crawl around in response to predators like sea urchins. There's one lying down, and just in the last minute or two here, can I get this, hover over it? There we go. So these guys can lie down and crawl around. I won't show the whole video because I don't have time, but there's one last thing I want to talk about. And that is we keep finding new species. So I've dived these places a bunch of times and still find new things. Oops, that was backwards. So I found this new species in 2009. It looks like a little palm tree. We found 3 specimens of it. And it turns out that instead of having the 5 basic rays of a crinoid, my 3 specimens had 8, 14, and 15 rays. And there's a larger specimen. And I view this as the equivalent of finding a 6-legged tiger in the Everglades. It's the first record of the genus in the Western Atlantic and a unique anatomical feature. And I view this, in 50 million years, this might be a whole new group. If you went back 50 million years, you would never have said these 4 little mammals running around were in a different family. But subsequently, we've got, tapirs, titanotheres, rhinos, and horses. So you never know where these things are going to lead or what you're going to find. And they're my co-authors and sponsors, and thank you very much.